What's up, guys? Welcome back to the channel. Today on this video we'll be calculating minors and cofactors. So in this video I'm going to show you how to calculate a minor and a cofactor for the third order matrix. So I'm going to also show you the difference between the minor and the cofactor. So before we continue, there is a super thanks button. If you want to support the channel, if you want us to provide you with the high quality content, you can help by hitting the super thanks button, and that will be highly appreciated. But if you can't hit the super thanks button and you also want to see the channel grow and you enjoy our content, do not forget to like, share, comment, and also subscribe to the channel if you haven't subscribed to the channel. We're going to start by introducing you guys to the 3 by 3 or third order matrix, and then we're going to explain and show you the calculations of minor, and then afterwards we're going to do the cofactor. Then I show you the difference between the cofactor and how to apply it on a third order. All right, so let's continue. Let's start with the square matrix for third order. So the square matrix for third order, it looks like this. You're gonna have entries that are about 9. So let's start with the first entry. Let's call it A11. The second entry, let's call it B12. The third entry, let's call it C13. This is the first row. Now the second row, let's call it A21, B22, and C23. There we go. And then the last row, we're gonna have A31, B32, and C33. Let's say this is our square matrix for the third order. Let me first remind you guys what we call it the square matrix. We call it the square matrix because it has the same set of rows as with columns. So it has 3 rows. As you can see, we have row number 1, row 2. It also has 3 columns. It has 1, 2, and 3 columns. So this here, we call it 3 by 3 matrix or third order. Now, the reason we call it square because we are multiplying 3 with 3, and that becomes 3 squared, or the square matrix. Now, what is the meaning of these numbers next to our variables, our A, B, and C? Now, these numbers here, I'll make an example. Let's say you have an entry, let's call it M. That entry has I and J. So this I represents row. So I represents row of this entry here. And then J represents the column of this entry here. An example could be A21. Now, A21, it means that this entry here is on the second row, but the first column. There we go. If you can look at A21, it's actually on the second row, as you can see, but the first column, as you can see, here's our A21 there. All right, so basically that's what these numbers mean there. You need to know about these numbers because they will help you to able to calculate the minor if it's given in this manner. Now that we've managed to explain these numbers next to the entries, we can move on. But before we move on, if you didn't understand, I've made a video introducing the determinants. You can go to that video. I also explained this again. So go to that video. I will leave the video in the description, and also the very same video will pop up on the top right of the one that you're watching at the current moment. Now from here, let me show you how to calculate the minor. What you should know is each and every entry here, it has a minor. So how do you actually calculate the minor of this square matrix? It's very simple. Again, I'll make an example. For an example, let's calculate the minor of maybe A31. So they say find the minor of A31. How do you actually find the minor of 31? It's very simple. What you do, you use 31 as your reference, meaning any column and any row that is associated with A31, you must cancel them. So for example, A31 is here, as you can see. So this column is going to be subtracted, and also the row as well is going to be deleted. So minor for A31, you must do the following. You must calculate the determinant of the remaining entry. So you will be left with E12, C13, B22, C23. There we go. So this is how you're going to find your minor. Very, very simple. All right, when you calculate the minor for A31, you must use the square matrix that you got here based on eliminating the rows and the column of A31 to calculate the determinant. So when you calculate the determinant, we know that we multiply the first entry. In this case now is going to be B12 with the last entry. In this case is going to be C23. And then the product of these two entries is going to be subtracted by the product of the following entry, which is C13 and B22. Guys, this is how you calculate the minor of A31. It's really not that difficult. Basically, you're calculating the determinant in the square matrix of the third order. That's what you're actually calculating when you calculate the minor. In order for you to know how to calculate the minor, you need to know all this information that I just showed you. Just in case you don't know how to calculate the determinant, I've already left the video on the description. Go to the description, click on that video, and also there is an icon on top right. You can click on that icon and watch the video where it explains how to calculate the determinant. So this minor here that you see is how you calculate the determinant. The question for this example was straightforward. They wanted you to find the minor of A31. All right, guys, I just showed you how to calculate the minor. How about we use the actual numbers to calculate the minor? Right, I'm going to write the square matrix with actual numbers, and then we'll try to calculate the minor using the actual entries. All right, guys, let's look at this square matrix that you have here. As you can see, this is also 3 by 3 or the third order. We have 3 columns and also we have 3 rows. So let's look at the first question. The first question goes like this: find the minor of -2. Now, when you look at the square matrix here, the -2 is here, guys. You guys see it. Now, when you calculate a minor, remember you have to scratch the row and the column of that entry. So our entry here is -2, so we need to scratch the row here, and also we need to scratch the column there. This means that we need to recreate the square matrix for the minor. If we calculate the minor, it's going to be the square matrix that is left there. What is our square matrix that is left there? We are left with 1, 2. For the first entry, it's 1 and 2. And then for the third and fourth is -3 and -4, respective. -3 and -4. There we go. And then from there, we calculate our minor. But remember, when we calculate our minor, it's more like we are calculating for the determinant. So I'm going to continue with this one underneath here. Now, when you calculate the determinant, we know that we multiply the first entry with the last entry. So our first entry, which is going to be 1 multiplied by -4 there, minus. Always you minus with the product of these entries here, which is second entry and the third entry. There we go. And then this is going to give us -4, and then that one is going to give us +6, meaning our answer here is going to be 2. So our minor for -2 is going to be just +2. Right, as you can see, this is how you calculate your minor, guys. Now let's do number 2. So I'm going to do number 2 this side here. Again, number 2, look at this. They say minor of M31. So this M just stands for the entry. So don't get confused. It means that we're going to use the entry that is on row 3 and column 1. Remember, this represents row for I, and then that one represents J for column. Let's look at this. Let's start with our row here. Our row, which is 3, so it's underneath here. And then our column, which is 1, is going to be the first one. So meaning this entry here, M31, is actually this -3 on our square matrix. So we need to cancel the row and the column of this entry. So let's do it. Right, we erase the first ones. So let's erase our first column. There we go. And our row. Now, meaning the matrix that you're going to be left with here is going to be 2, 3, -1, and -2. So when we calculate it, we're going to have the following matrix here: 2, 3, -1, and -2. Guys, do not forget how we got to this. Remember, we use these J and I. Now we calculate the determinant. So when you calculate the determinant, remember you multiply the first entry with the last entry, which is -2 there, minus by the product of the second entry and the third entry. Now this here is going to give us -4. This is going to give us 3. So our final answer here, or our minor here, is going to be -1. Meaning now, minor for M31 is equaling to -1. Guys, basically, this is how you calculate a minor if you are given a question of this caliber. Just in case you haven't subscribed to the channel, subscribe to the channel, because I have made lots and lots of videos, guys. And also, don't forget to like the video if so far this information is helping you. Now, let me show you guys how to calculate the cofactor. All right, guys, now that we managed to explain the minors, how about we explain the cofactor? Now, a cofactor is basically a minor multiplied by -1 or 1. So it depends on the entry. Sometimes it could be multiplied by -1. Sometimes it could be multiplied by 1. The entries are the one that determine which one is negative, which one is positive. So let me just show you what is meant by that. Let me show you one of the formulas that we use to calculate the cofactor. So when you calculate the cofactor, this is the formula. Inside the bracket, you have -1 to the power of I plus j multiplied by minor. There we go. So this I and j, they're going to be based on the entry that we are looking for the cofactor from. Let's say, for example, we say to you, find the cofactor of maybe A21. Now, it means now on A21, you want to insert inside the bracket -1, but then as you can see, we have 2 and 1 there. We know that 2 is for I and 1 there is for j. So as for exponent, you're going to add 2 plus 1. There we go. Multiply by the minor. It means now this is going to have -1 to the power of 3 multiplied by minor. Meaning, if we put this on a calculator, we're going to have -1 multiplied by minor. I hope you can able to understand this. Basically, this is what they mean when we say calculate the cofactor. Sometimes you can say calculate the cofactor. For example, you can say find the cofactor of maybe M33, right? Remember, M basically means the entry there. So this M33, where is it? Is this term here or that -5? So we're going to use numbers later on. Now, if they say calculate the cofactor of M33, remember, 33 means the third column and the third row. So these two are actually the ones. So I'm going to use this C33 just for example. So if you use the formula is going to be like this: -1, and then we know that I is 3, J is going to be 3, so it's going to be 3 plus 3 multiplied by minor. There we go. We just calculated minor earlier on, so you must be able to know how to calculate the minor. Right, so we know that this is going to be -1 to the power of 6, and then multiplied by minor. If you continue further, the -1 to the power of 6 become +1, then multiplied by minor. So the difference between the two is that the other one, the first one here, we were multiplying by -1 because of our exponent is an odd number here, going to give us 3. And then the second one here, we multiply by +1 because our exponents here, they're going to give us an even number. Hence, we have a +1. So hence, we say a cofactor is a multiplication of -1 or 1 with minor. Or you can say it's a product of a minor and -1 or 1. So basically, that's what it means. So this is one of the formulas that we have, guys, here. The formula, it goes like this. It's -1 to the power of I plus j multiplied by minor. Now, if you don't want to use this formula, another way of calculating the cofactor, you can use the signs. The signs are very simple. The first entry, it's always positive, always. Now, from there, you just alternate the signs. Whether you go to the left or you're moving downwards, you just alternate the sign. Next to positive, you put negative. Next to negative, you put positive, and so on and so on. If you go downwards, it's still the same. The first entry on the column is going to be positive. The second entry on the column is going to be negative, and the third one is going to be positive. You just alternate. Then from there, you just alternate the signs, right? The signs. This here, guys, you also call them cofactor signs. So this one here, you can use it also to calculate the cofactor. Just in case you don't like to use the formula, you can use the signs. Now let me make an example on how to get the cofactors using this method here. Now it's very simple. Let's say we use this signs here or this method to calculate the cofactor of A21, the one that we did earlier. Now instead of using the formula, we're going to use the cofactor signs here. Now you need to know where is A21. Now we know that 2 stands for the row, so we know that that A21 is going to be on the second row. But the column now, we know that this one stands for the column. So the column is going to be 1. So meaning we're just going to take this sign and then we multiply it by our minor. There we go. So we're going to say the cofactor of A21 is going to be minus, taking from this sign here, multiplied by the minor. Remember, we did the minor earlier on this video. So I'm going to show you guys how to do this with numbers for both the method. So I'm going to erase everything here and try to use the both method to calculate the cofactors. All right, guys. So we have these questions here. Question 1, they want us to find the cofactor 4, and then we need to find the cofactor for M23. So we're going to start with number 1, where we need to find the cofactor of the entry 4 there. Now, I'm going to use both methods to find the cofactors for number 1. Now, let's start with the method where we use the formula. Now, if we use the formula, we need to understand what entry is this one. M21. There we go. It's on the second row, but the first column. So hence we have 2, 1. Now, if we use the formula, this is very important, guys. You need to know your J and your I. So the formula goes like this. It's going to be -1 to the power of I plus J. There we go. Multiplied by minor. Now let's continue. So we know that this -1 is just a number. You're going to put it there. Now, what is our I? The row there. What is the row for 4? Now, the row is the second row. If you can look, we have 1 and we have 2 there. So we can say this is the second row there. I represent the row. And then the column, which is represented by J. Which column is this one? So it's the first column. It's 1, 2, and it's 3. So you say plus 1 for first column. There we go. Just erase this very quickly. Now we are done with J and I there. Now multiply by our minor. Now our minor, how do we get our minor? Remember, we need to find the matrix for this minor. So what do? We delete the row where 4 is and the column where 4 is. So our matrix that we left with here is going to be 2, 3, -4, and -5. So when you calculate the minor here, it's more like we are doing the determinant. So it's going to be -1 to the power of 3. Remember, this is 2 plus 1, right? So that makes it 3. And then multiply by, so what is our determinant here? It's going to be 2 multiplied by -5 minus the product of 3 and -4. And this is going to give us our cofactor. We know that this one here, -1 to the power of 3, is going to give us -1. And then our minor is going to give us -10 plus 12. There we go. Let me just move number 2. If you continue from here, we know that outside we have -1. Inside the bracket, we're going to have +2. So meaning our cofactor is going to be -2 when we use the method of the formula here. But what happens if we use this method of the signs then? So I'm going to need more space so that we can compare the two. Let me just erase this question first. All right, let's use alternative. Let me just write out there. Right, so when you use the alternative method, remember we have to use the signs here. The signs are very simple, guys. The first entry is positive, then from there you just alternate the signs. The second entry is going to be negative, third entry is going to be positive, and so on and so on. So what you do here, guys, you just multiply the minor with the sign. All right, so we need to know how to represent this 4 here, which is our entry. So this is very important. M21 is very important. This 21 here. This 2 here basically means that our row is the second and our column is the first. Now when you look at the signs there, this is the sign there where our row is the second and the column is the first. So what you do here, you multiply this sign with your minor. Remember, this doesn't change. You're still gonna scratch the first column and the second row so that you can have your minus. So you multiply the square matrix that is left there with our sign. So the square matrix is 2, 3, -4, and -5. And then you calculate the determinant. All right, we're gonna continue here because you don't have enough space. Now let us not forget that we have this negative here, so we need to include this negative there. So let's include it. Then from there we have the bigger bracket and the smaller bracket. So inside there we need to calculate the determinant. Remember, when you calculate the determinant, you multiply the first entry, in this case is going to be 2, multiplied by the last entry, in this case is going to be -5, minus by the product of the second entry and the third entry. Then you close the bracket. Now remember, we have this negative here, so inside the bracket there we're gonna have 2 multiplied by -5, that's gonna give us -10. So on the next term we have negative and negative, this is gonna give us plus, and then 3 multiplied by 4, that is gonna give us 12. So inside the bracket there, if you can pay attention, inside the bracket we have +2 multiplied by negative, so meaning our minor is going to be -2. As you can see, these answers are the same. Now you choose which one would you like to use, or which method would you like to do. But both of them, they are simple and they're straightforward. So if you decide to use the formula, which is this one here, just make sure you know how to allocate your entries using your J and I, these ones here. Right, but if you decide to use this method where we use the signs, do not forget that the first entry is positive, and then the rest, they just alternate. Positive, negative, positive, negative, positive, negative, until you get to the last one. And let us not forget to erase the row and the column of the entry that you're looking for the cofactor of. All right, guys, we are done with this question here. Let's do the second question, where you are given a question in terms of entry location. Right, let's look at this one here. This was the second question. They want us to find the cofactor of M23. Now, M23 is entry at row 2 but column 3. So what is that entry? Let's start it. Our row 2 is here. So meaning we have to scratch row 2. There we go. Our column is 3, as you can see there. So we have to scratch column 3 there. As you can see, this means that this -2, we are finding the cofactor of it. Two methods. So we're going to start with the one with the formula, and then we're going to do the other one where we use the cofactor signs. So let's use the one with the formula. Remember, the formula is so simple. It goes like -1 to the power of I plus j multiplied by minor. There we go. Now, let's look at this. -1, our I is our row. So row is 2 there, plus j. Our j is our column, which is going to be 3 there for this one, multiplied by our minor. Now, our minor, when you look at what we're left with here, we're left with 1 and 2. We're left with -3 and 4. There we go. When we continue here, we're going to have -1 to the power of 5 multiplied by our determinant, which is going to be 1 multiplied by -4, which should be like that. 1 multiplied by -4 minus the product of 2 and -3. There we go. Now, if you continue, this -1 to the power of 5 is going to give us -1 multiplied by what is inside the bracket there. This is going to give us -4 minus this is going to give us 6 plus 6. So when you continue here, it's going to give us -1. Inside the bracket there, we're going to have +2. So this here is going to give us -2 as well. What a coincidence. So when we select this entry here, the cofactor of this entry is going to be -2. It has nothing to do with the actual entry, which is -2. It just so happened that it's also -2 as well. All right. So this is the other method that we use to calculate the cofactor. How about when you use the other alternative method? Then, now it's very simple. Again, you look at where M23, so entry 23, we know that it's on the second row. Okay, here's our second row and the third column. So it's going to be there. As you can see, when you use the sign there, is going to give us negative, right? So we say negative multiplied by the minor. Again, that will require you to go back to your square matrix that has numbers and delete the column and the row of that entry. Now, if you continue here, we say minus, and then the square matrix that is remaining is 1, 2, -3, and -4. And then we calculate the determinant. Again, you multiply by -1 there, and then your determinant is going to be as follows. We have 1 multiplied by -4, it's going to be 1 multiplied by -4 minus by 2 multiplied by -3. So minus 2 multiplied by -3 inside the bracket. Let me just create a little bit of space here. If you continue, don't forget we have this negative here. So inside the bracket, we have this 1 multiplied by -4 is going to give us -4. We have minus multiplied by 2 multiplied by -3. This is going to be -6. Give us +6. We're going to have negative, and then inside the bracket, we'll be left with +2. So this makes it -2. Again, this method also is going to be giving us the same answer as the first method. Guys, I hope you managed to understand this. Really, it was not that difficult. When you calculate cofactor, you just have to know these two methods here. It's either you use the formula, which is this one here, or you use the cofactor signs. Now, the difference between the two, the minor is actually the determinant of the entry in the third order or more, whereby the cofactor is actually the sign multiplied by the minor. There we go. That's the difference between the cofactor and the minor. I've made those examples. I hope you will understand them because you're gonna use them when you calculate the determinant in the third order. So you needed to know the difference between the cofactor and the minor. I hope this makes perfect sense. On the next video, I will show you guys how to use the cofactor and the minor to calculate the determinant. Alright guys, thank you very much for watching. If this information helped you to understand, do not forget to like, share, comment, and subscribe. If you want to support our channel, you can always hit the super thanks button there. Thank you very much for watching. Till next time, cheers.